Let's look at this second part of example 1 here and being able to solve, or excuse me, add and subtract rational expressions. So let's take what they've got. They've got 2x over 9y minus 7y over 6z. It'd be helpful here if you know how to find the least common denominator between these two. It helps you in simplifying further, or furthest simplifying when you get to the end. It'll just save you a little heartache at the end. So what is the common multiple, the least common multiple between 6 and 9? Well, that puts us at 18. So we know that we got to multiply this by 2, but then it also has to have a z in it because there's a z over here. And so I got to multiply top and bottom here by 2z. And then 3 times 6 gives me 18. So I'm going to write 3, and there's a y over there. So I'm going to multiply top and bottom by 3y. And that gives us that common denominator. So if you multiply this together, you know that it's going to be 18yz. Put a little slash there to help us know it's not a 2, like right up here. My 2's are terrible. They almost look like z's. But anyway, and then you know, like you can look over here. 6 times 3 gives me 18. That's going to give me yz. So I know I've got my common denominator. And now I combine the top. That's going to give me 4, 2 times 2 there, xz minus my 21 y squared. So that's how to simplify, and that's in simplest form, guys. There's, 21. Got to get a 1 in there. There's no common multiples between 421 and 18. So rest assured, the numerical values are in their simplest form. And then, you got this x, z, and y business going on in there. All of those, that's completely simplified. That's the simplest form, rest assured, for that particular problem. All right, so let's go on. Let's look at example 2. Things get a little more interesting in example 2 because you should recognize there that you've got a quadratic. And then you also have, looks like to me, a common multiple in the other denominator. So let's write this down, and you'll see this as, what do we got here? We got 2x plus 1. They've got that all over the top of x squared plus 2x minus 15. And this is quite a step up in this problem from your previous work. This is where things kind of get a little hairy in being able to understand what the heck is happening here. Common denominators are the key. I would encourage you to go slow and really think things through. The first thing I recognize in this problem is that indeed we have a quadratic. Anytime you see a quadratic, the first thing you should do is factor it if you can. X squared plus 2x minus 15. So in all of our experience, we're looking at the factors of 15 that give us that 2. I'm not going to spend a bunch of time there. You have to be able to bring that forward from your past learning. This bottom is going to factor into x. What is that going to be? Plus 5 times x minus 3. This is going to be able to help you in doing that factoring to set off and see, well, what do I need in my other denominator so that I can get this common denominator to put these together. So if you factor out the 5, hey, look, there's an x minus 3 there as well. So I have an x minus 3 in both of these. I don't have to worry about that. But I certainly have to worry about getting a 5 in both of them. Well, there's already 5 in the first one. And I got to get an x plus 5, in the second one. I got to get an x plus 5 in the second one because of what you see in the first one. So in essence, this x plus 5 and this 5 are going to have to be multiplied into both of those, not simultaneously. So all this missing here is going to be the 5. So I'm going to multiply top and bottom here by 5, parentheses on top there. And then here I need to multiply by x plus 5. And once you have all those factors written in there, rest assured you're going to have that common denominator. There's a 5 being multiplied in the first one times an x minus 3 and an x plus 5, and a 5 times an x minus 3 and an x plus 5. They're not in the same order. That doesn't matter because the multiplication, they're all there. So now let's just keep going here. And so further, I'm going to go ahead and multiply that out. That's going to give me 5 times, at least I'm going to go one step further, this x squared. It's going to be minus, how about plus 2x minus 15. Now you might be asking, well, why did we factor it? We're back to what it was. Again, that was to help us in finding that common denominator in the second expression. So in that first one there, I'm going to multiply the 5 through. I'm going to take the 5 times the 2x. That's going to give me that 10x plus 5. Careful here. You got a minus between them. So if I were you, I would write parentheses for the second part because you know when you multiply 7 times x plus 5, you get this, but all of it's being subtracted away from, all of it is being subtracted away from the 10x plus 5. All right, moving on. This simplifies into 10x plus 5 minus 7x minus 35. And that's all over the top. 5x squared plus 10x minus 75. All of a sudden, my dogs are getting all fired up here. So you're hearing them flap their ears in the background. Sorry about that. Guys, chill out. All right. So then what does this simplify all the way into? So if we further simplify this, our 10x and our 7x give us 3x because we're subtracting that 7x off there. And then I've got a positive 5 and a negative 35. So that's minus 30, 3x minus 30, all over our 5x squared plus 10x minus 75. It's minus sign there. All right. So check that out. That's actually back in, what page is that? Page 460. And you can see that they have left the bottom in factored form. I've went ahead and multiplied it out. I'd encourage you to do that. Okay, guys, I'll see you in the next video. We'll look at a couple more examples here. Example 3 and example 4. Those are going to be taking us along the way here, a little more difficult as we go. We're going to look in example 4 specifically at what are called complex fractions. All right, see you in the next one.